welcome to the practice problems video for volumes of revolution. Okay, for this question, we're going to sketch the region enclosed by y equals x squared plus 2 and y equals 10 minus x squared, and find the volume of the solid obtained by rotating this region around the x-axis. Okay, so first of all, we're just going to sketch and see what we're looking at. Okay, so here's our x, here's our y. I'm going to go by tens so we don't have to count too far. Right, so this is 5, 10. Then this is going to be 5, 10, and then this is also going to be negative 5, negative 10, okay, and then we're not going to be dealing with below the x-axis. So, okay, so here's our first one. We're going to, it has a y-intercept of 2, and then we open up into our normal parabola, right? So then we have something like this, okay, an upward-facing parabola based at 0, 2. Okay, so this is our x squared plus 2. One, and then our other one is based at 0, 10. But this was a downward-facing parabola, okay, because it has that negative in front of the x squared, okay? So this one here is our 10, so 10 minus an x squared, okay? So we're dealing with this region here, and what we want to do is rotate it around the x-axis, so something like that. Okay, so let's look at it. We're going to identify what is our capital R and what is our little r. So here's our axis of rotation, so that would be the x-axis, which is y equals 0. Alright, so if we're starting there, we're going to base our point here, and we're going to go up to the bottom border of our region, okay? So this is going to be this graph, so that'll be our little r. And then we're going to do the same thing. We're going to base it at the x-axis, or our axis of rotation, and then we're going to draw our line up to the far point of our region, to the far border there. So that'll be our capital R. Sorry if it's kind of messy in there. Hope you can see that. So what is our capital R and what is our lowercase r? So capital R is given by top minus bottom. So the top function is actually a 10 minus x squared, and minus bottom, so that would be y equals 0, so just a 0. So we're going to get that this is equal to 10 minus x squared. Okay, and then the bottom one, or the lower one, our little r is going to be top minus bottom. So the top function here, this is our x squared plus 2 graph, so x squared plus 2. And then minus the bottom function, which is a 0 again, so we just get x squared plus 2. Okay? So now that we have our capital R and little r, we have to determine what is our interval, our A and B. Okay? So where are we going, how much are we going left and how much are we going to the right? Okay? So to determine that, we have to find the intersection between these two graphs, right? So this point here and this point there. Alright, so to find the intersection, we just set them equal to each other. So we're going to say x squared plus 2 is equal to 10 minus an x squared. So when we do that, then we kind of just rearrange, right? So we get 2x squared is equal to an 8. And then we get that x squared is then equal to 4. So x is equal to a plus or minus 2. So x is equal to plus and minus and or minus 2. So that means that our interval is going to be a negative 2 up to a 2. Alright, that's our x interval there. And then, of course, we're going to be integrating along the x-axis, right? So that means dx. Okay, so let's put all of these pieces of information together on the next slide, and we'll apply it to the formula. So we have capital R is given by the formula 10 minus x squared. Little r is given by the formula x squared plus 2. Our interval is from negative 2 to 2, and we're integrating along the x-axis in the x direction. Okay, so if we apply that, we get v is equal to pi times, so our interval is from a to b, and then we have capital R squared minus little r squared, and then dx. So if we plug all of our information in, we get pi times the integral from negative 2 up to 2 of capital R is going to be 10 minus x squared, quantity squared, minus little r, which is x squared plus 2, quantity squared, and then our dx, of course. Alright, so let's just FOIL this out, really. So we have the volume is going to equal to, the pi is just going to hang out there in the front for quite a while. And then we get 100, and then this is plus an x to the 4th, and then minus a 20x squared. Okay, and then we have minus, and in here we have an x to the 4th as well, plus a 4, and then plus a 4x squared. Okay, so a lot of stuff going on in there, and we're just going to simplify here. So we get v is equal to pi times the integral from negative 2 to 2 of 100 plus x to the 4th minus 20x squared minus an x to the 4th minus 4 minus 4x squared. So there I just distributed the negative. Okay, so we can see that the x to the 4ths cancel out, and we can combine the 100 and the 4 and the negative 4 to make a 96. So we get, here I'll squish it down on the bottom slide, and then I'll rewrite it on the next slide as well. So integral pi times the integral from negative 2 to 2 of a 96 and then minus a 24x squared and then a dx. Okay, so let's continue this on the next slide. So we're at the volume is so far equal to pi times the integral from -2 up to 2 of 96 and then minus a 24x squared and then times dx. Okay, so if we integrate, we just get that pi just stays in front and we have 96x and then minus a 24 and then x to the third, 1 over 3. And then this is going to be evaluated from -2 up to 2. Okay, so these ones cancel, that makes an 8. Alright, so that simplifies our lives a little bit. Okay, so then we have v is equal to pi times 96x minus 8x cubed, and this is evaluated from -2 up to 2. So if we plug things in, we basically just get v is equal to pi, and that'll just stay outside like I said. So then we get a 96 times +2 minus an 8 times +2 cubed, and then we have a minus a 96 times -2, okay, and then minus 8 times a -2 cubed. Alright, I think I have enough parentheses now. Okay, so then we have v is equal to pi times, and 96 times 2 is a 192, and then we have 8 times another 8, so that's a 64. Then we have plus, this turns into plus because we have two minus signs, right? So plus plus, and then we're going to have a plus over here as well. Well, no, we're going to end up with a minus because that's negative, 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 so we have the minus for the second one. Anyway, so we have a plus 192, and then minus another 64. So this eventually turns out to be, when we calculate this all out, this is a 256 pi. Okay?